So the first part of the problem session we discussed up to question number 15. Now we are going to discuss the another question. So the Young's modulus of the material of the wire is given by, so question number 16. So I can write this is question number 16. So Young's modulus y is given, so y is equal to 2 into 10 to the power of 10 Newton per meter square. And next is elongation of the strain is delta L by L in percentage error. They are given 1%. 1% is nothing but 1 by 100, that is equal to 10 to the power of minus 2. And the energy stored in the wire per unit volume in joule per meters cube. So energy per unit volume is nothing but energy density, that is equal to, we know that half into stress into strain. So this is the data given to us. But you see that stress is not given. So we have to replace the stress in terms of a known quantity. So y is equal to sigma by epsilon, that is stress by strain. Therefore sigma is equal to y epsilon. So we can write that 1 by 2. This has to be y epsilon into this one. So strain square. So this is square. So therefore 1 by 2, y value is given, this has to be 2 into 10 to the power of 10 into epsilon square. This is given as to be 10 to the power of minus square is there, therefore minus 4 will be there. So 2 gets cancelled out, we can get 10 to the power of 6 joule per meter cube. So this is the answer for the question number 16, 10 to the power of 6 joule per meter cube. Now we please go for question number 17. So question number 17. A 5 meter long wire is fixed to the ceiling. A weight of 10 kg is hung from the lower end is 1 meter above the floor. The wire was elongated by 1 millimeter. The energy stored in the wire is. We just see this equation. So the question. So a 5 meter long. So L is equal to 5 meter given and is fixed at the ceiling, and that M is equal to 10 kg. M is equal to 10 kg hung from the lower end and 1 meter above the ground. The wire is elongated by, so therefore delta L is given as to be 1 millimeter. So that is equal to 10 to the power of minus 3 meter. And we have to find out what is the energy stored in the due to the stretching of this one. So we know that energy is stored, yes. So therefore U is equal to, just to find this, there are two formulas. One is in terms of spring energy, we studied that U is equal to half K x square or K into delta L square. This is one general format for a spring system. And for in case of elasticity, U is equal to half. Yes, we wrote that that has to be F average into delta L. These are the two important things what we must consider. So now we please come for this discussion. So U is equal to, so which formula we have to select, that is our given data will decide. So therefore U is equal to, I can go for F into delta L. So here F is nothing but the weight of the rod. So therefore I can write that 1 by 2 F is nothing but M into G. So M into G into delta L. So therefore U is equal to 1 by 2 into, mass is given as to be 10 kg. So 10 into 10 100. So therefore 10 into 10 into delta L is 10 to the power of minus 3. So minus 3. And this is cancelled out, minus 1. This is 1 by 2, 0.5. 0.5 into 10 to the power of minus 1, that is 0.05 joule. So this is the answer for the 17th question. Now we please go for question number 18. So question number 18. So just see that question number 18. The two wires of same diameter of the same material. So same diameter is given. So I can write the given data for question number 18 here. So therefore question number 18. So same diameter is given. So therefore diameter is same, then we can say that area also same. And the same material, therefore y1 is equal to y2 also. And having the length L and 2L. So therefore L1 is equal to L and L2 is equal to 2L is given. And the force F is applied on each. So force also is the same. So the ratio of the work done in these two wires will be. So therefore force also same force is applied over there. Then we have to find out what is the work done value. So work done is nothing but potential energy. So work done, that is nothing but, these are the data given to us. So therefore 1 by 2, this work done is nothing but potential energy of the system. And we wrote that stress into strain into volume. So this is the general expression what we have. So therefore W is equal to, so W is equal to, so you just see that 1 by 2, and force is same. So stress, force by area, stress is constant. So same force is there and the same area is there, therefore F by A, sigma is constant. So sigma is constant into strain. Strain is nothing but delta L, and here we are not getting any strain term, so we have to replace this strain in terms of the known quantity. Therefore strain can be I can replace the strain. So y is equal to, we can write y is equal to sigma by epsilon, from this epsilon equal to sigma by y. So I can write here also, so sigma divided by y into volume is there. Volume is nothing but area into length. So area into length. So now you see that same area, same sigma and y, everything is constant. Therefore I can write that W is proportional to L. So therefore the work done required for that one is W1 by W2, that is equal to L1 by L2. That L1 by L2 is nothing but just a substitute value here. Therefore L by 2L, that is equal to 1 by 2. Therefore, so W1 by W2, that is nothing but 1 is to 2. So that is option A is the correct answer. Now we will go for question number 19. So question number 19, it's very easy one to solve such type of matching question. So you see that the mud is nothing but whenever the external deforming force is removed, there is no regain of shape. Therefore mud is nothing but plastic material. So A should be 3. So now we check the options. So except what is that A, C, D, except that 3 options, you just check the second option. A starts with A to 3. So mud is a plastic material. So obviously in match the following cases, we can omit the unwanted options by checking the specific data. Therefore mud is a plastic material. And the second one is B. Steel is elastic, since it has the high elastic material, and rubber is elastomers. So the copper is obviously compressor. Therefore for 19, the answer will be B. Now you please go for question number 20. So question number 20, now you see that a stretched rubber as, we know that whenever a rubber is stretched, we know that the external work done will be stored as a potential energy in that is given as to be as U is equal to F average into delta L, that is F by 2 into delta L. Therefore whenever the rubber is stretched, delta L increases, therefore increase in. So when delta L increases, the U also gets increases. Now you please go for question number 21 also. So 21, so now you see that 21, 2 wires of the same material. So now you see that in question number 21, in 21, 2 wires of the same material, same length. Therefore y1 is equal to y2, and they are giving same length, same length, L1 is equal to L2, and but diameters are in the ratio. So D1 by D2, that is given by 1 by 2 in the question. So stretched by the same force. Therefore F1 is equal to F2 also. So by energy per unit volume of the 2 wires. So we know that energy per unit volume, small u, that is equal to of stress into strain. This is the data given to us. So therefore here we are not getting any delta L term. So obviously epsilon or strain is replaced. So strain can be replaced by this one, epsilon equal to sigma by y. Therefore the strain can be written as sigma by y. So what I can get, u is equal to sigma square by 2y. But for this material y is constant, and so therefore we can see that sigma is nothing but f square divided by a square into 2y. Same f is given, so that is considered to be constant, and the same y also given, that is considered to be constant, but their diameters are different, so we cannot take that a has to be constant. Therefore I can write that, so u is inversely proportional to area is nothing but pi r square, r is nothing but d by 2, that whole square is. So therefore I can get d power 4. So from this I can get that, so u1 by u2, that is equal to d2. So d2 by d1, that whole power 4. So therefore d2. So just to reciprocate that, we can get 2 by 1, that whole power 4, that is 16 is to 1. So that is the answer. So copy that solution, children. So question number 22, Young's modulus of the material is given by wire is y. On pulling that wire by force F, the increase in length is x. You try to understand, student, as I said earlier, they can give the or change the notations. Whatever may be that what we study is W equal to U, that is equal to F average by F average into S delta L. Therefore 1 by S2 into F into delta L. So delta L here, that is given as to be x, therefore we can write delta L as to be x, so I can write W is equal to half F into x. So this is the correct option for question number 22. Now we please go for question number 23. So when a 4 kg mass is hung vertically on a light spring that obeys the Hooke's law, the spring stretches by 2 centimeter. And the work required to be done by the external agents in stretching this spring by 5 centimeter will be. So generally we know that a wire can be treated as a spring with the as a spring constant K is equal to S YA by L. A wire can be treated as a spring with the spring constant K is equal to YA by L, Young's modulus, area and length. Now we please see that question. 4 kg mass is there and we have to be stretch that. Vertically as light spring, Hooke's law is there. So the work done generally is work done or energy, that is W, that is equal to half K into x square. In spring the potential energy is given by, potential energy is given by half K x square generally. Here the extension is given as to be as delta L or delta x, so we can reformat that half K delta L square here in this case, in elasticity case. Therefore I can write that half K into, there's the new another length 5 centimeter, we have to make the change in that. Therefore I can say that that has to be delta L2. For 5 centimeter I can take that has to be delta L2, and 2 centimeter I have to take that initial length. Therefore 1 by 2 K can be written as, so we know that F is equal to K into delta L, therefore K is equal to F by delta L. So now you take that value, so F by delta L1 into this is a delta L2, that whole square. So now you see that 1 by 2, F is nothing but M into G. So F is nothing but M into G. So M is given as to be 4 kg. So M into G, since they are given 9.8, we must use 9.8 instead of 10. So mg divided by delta L1, that is 2 centimeter. So 2 into 10 to the power of minus 2. This is what that will give the K value or F by delta L1. Into L2 square is there, that is 5 into 10 to the power of minus 2, that whole square. So by solving this we can get the answer has to be is approximately 2.450 joules. Just to do the numerical part, that I can leave it for your practice. Now please go for question number 24. So now question number 24, an elastic string is unstretched length. The initial length is L and force constant is K, and it is stretched by a small as length, so x. So let us consider the initial potential energy in the spring is given by half K as per the question, that is x square. Now it is further stretched by the another small length. The same wire is, first equilibrium length is L, then it is stretched to x, again the same wire is stretched to some other new length y. So therefore the total extension from the, when compared to the equilibrium length or original length, that is, so U final, that is equal to half K into x plus y, that whole square. So they are asking what is the work done in the second stretching. So generally in mechanics we studied that work done is nothing but a change in potential energy. External work done is nothing but change in potential energy. Therefore U final minus U initial. Therefore I can write that W is equal to, just do that, half K x plus y, that whole square, minus half K x square, children. So the common term is taken outside, half K is taken outside, then x square plus y square plus 2xy and minus x square is there. So we can get that, as these two terms gets cancelled out, y is common here, so 1 by 2 K into y. So y is taken outside, then y is there, plus y is taken outside, 2x is there. So this is the work done to do the necessary change. So therefore just check the option, it is option D. So option D is the answer. Now we please go for question number 25. Question number 25. So in question number 25, you just see that The same question, I think so, because yeah, yes, 24 kg youngs were, yeah. So 25 is very similar to, yes, question number 23. So we can go for question number 26. So question number 26. If a wire of Young's modulus Y longitudinal strain is X is produced, then the value of potential energy stored in terms of unit volume. So just now we said, student, so small u, energy density, small u is nothing but of S stress into strain, yes. But you see that Young's modulus is given longitudinal strain. So instead of S epsilon, they are given that has to be X. So we have to give our answer in terms of Y. So therefore, the sigma can be written as sigma is equal to Y into epsilon. But here that strain is taken as to be X here. Therefore, I can write Y into X. Therefore, U is equal to 1 by 2. This sigma, that is Yx into X is there. So Y into X square. So therefore, 1 by 2 Yx square. Just check the options. Option D is the answer for that. Now you please go for question number 27. So the question number 27, again the same method. So I can leave it for this question as a homework to you. So as you did in the question number 26, kindly do the question number 27 for your reference. Answer is already there. So now you please go for question number 28. So question number 28. Yeah. So a metallic rod of length L and cross-sectional area A is made of material Young's modulus Y. If the rod is elongated by the amount, so again you just see that, children, don't stick on with the symbols. Here delta Y is given as to be Y here, small y. Even you may get the confusion with the small y with the capital Y. Please take care of that. So delta L is equal to Y. Now they are asking what is the work done. So generally work done is equal to 1 by 2 is, so force into delta L. Force into delta L, but instead of this delta L, they are given that has to be Y, so we can write that has to be 1 by 2 into delta L. Instead of delta L, small y is given, so small y is given there. Now we see that we must replace this F. So we just see the Young's modulus equation, Y is equal to FL divided by A into delta L. So from this delta L, they are given here has to be small y. Therefore, I can write that F is equal to YA delta L. In this question, delta L is given as to be Y. Therefore, I can write that YA small y. Y capital Y is Young's modulus. Small y is elongation in the wire or material. So therefore, F is equal to YA Y divided by L. So therefore, I can substitute here there. Therefore, capital Y A small y divided by L. Since for the same length we can say that YA small l will be considered to be constant. Therefore, I can write that W is directly proportional to small y, or we can say that W is delta L square in the general representation what we studied. But for this question, that delta L is considered to be Y here. Therefore, this is the answer. So the option is option C. So option C is the answer for this question. Now you please go for question number 29. So 29, just to see that. Yeah, so 29. 29 is very similar to 24. The total work done, external work done is nothing but change in potential energy. Similarly, the same matter, same way, or the method we can say that is external work done, that is equal to delta U, that is U final minus U initial. Let us consider that L1 has to be initial length and L2 has to be final length. Therefore, I can write that of the spring potential energy is already given is there. So like this we can use it. So we can write that K into L2 square minus L1 square, initial and final length elongations. Question number 30. So question number 30. Yeah, assertion, Young's modulus for perfectly plastic body is 0 because we know that there is no deforming forces or there is no restoring force when deforming force is removed. And the reason is a perfect plastic body restoring force is 0. So since why the material is called plastic or elastic means depends on the ability to regain its shape with the help of what is that, restoring force. So in this case, plastic material, there is no restoring force developed. So therefore, assertion and reasons are correct. So kindly, yes, these are the solutions for the question number 22 to 30. You please kindly copy that solution, students.